Hi, now it's time to take a closer look at how we can route audio signals in WebAudioXML. So far we have looked at the chain element and the mixer element and how they could either route the signal from top to bottom in the chain element or to mix the output of the different elements into the mixer's output in the mixer element. But now we're gonna override that, and this is where we're gonna see how it works in this example, routing signals, creating delay. And if you're not familiar with the structure here, please have a look at the previous examples, and that will be clear, hopefully. So in this example, we have a chain node with an oscillator, bipod filter, and a gain node as in previous examples. And the new thing here is this element, a send element with two attributes. One is called output and one is gain. And what this does is basically taking the output from the previous element, gain node, that comes into the send element, and because the send element is a bit special, it both routes the signal further into the next element, which is then, well, because it's the last element in the chain, it will connect it to the chain's output, but it will also connect it to anywhere specified with the output attribute. And it's specified using CSS selectors that is used in XML and HTML. So hashtag delay looks for another element with its ID set to delay. And it finds that element, it's this one, chain, another chain element inside audio. And it has its ID set to delay. So that means that this element is connected to this element's input. And this chain has one delay node, which is a native web audio node. And that delay time, which is a property in web audio, is set to 1000. And 1000 is here set in milliseconds, even if second is the time unit in web audio. And I added the support for either milliseconds or seconds, which is default in WebAudioXML. And you can set it anywhere in the structure, but typically you set it on the root element, the audio element, because then it's inherited for all the children beneath it. So all time values here will be using milliseconds as a unit. Let's listen to what it sounds like. So we get a typical delay, and this is how it works. We send the signal from this chain, but not with the original level, but we reduce it with 6 decibels. So that's kind of the send level, similar to a normal mixer send. The input comes into this chain, the signal comes into this chain, and it's delayed with 1 second, 1000 milliseconds. And the output from the delay node is connected into another send element, which is also outputted to the same chain. And that's how we create the feedback loop in the delay, as we normally do with delays. And that send level is also set to -6 decibels, making the next feedback being softer than the first one. And that delay will be even softer when it's feedbacked again. So we get this feedback loop that is with lower and lower gain value. So we get several bounces with the delay. Okay, we can change the delay time. And we can change the the gain of the send, which means that we get more bounces because they wouldn't reduce in the gain as much for each bounce. If we would set it to 0, that would be an infinite loop of delays. Which is not fun, or maybe it is. What we can also do, apart from changing the gain level, we could also add a quad filter node with the frequency set to, for example, 500 Hertz, and its default a low pass filter. That means that each bounce will be filtered using the backward filter node low pass function. So let's turn on the speaker and play. Both have the gain reduced and the backward filter node cutting off. So that's the creative way of using output routings and send elements. And I showed you this using the hashtag, which is referring to IDs. But if you're familiar with HTML, you know that there is also something called class that could also be used. But then you do the dot. So then you type dot delay, and it will look for all elements with the class set to delay in this case. That means that you could easily do like one node connecting to as many nodes as you want to by just having many nodes responding, or many elements responding to or set to the same class as the output is referring to here. So they will all respond to that kind of call for get my connections, and then the system will connect the output signal to all those receivers. So that could potentially be a really creative way of using the CSS selectors as well. So I think that's it for now. Thank you.